Alright, so we just got done going over words to review. You're going to want to take a look at those throughout the course of the Chapter 8, and especially before we take our test. But Chapter 8, Section 1 is entitled Model, Inverse, and Joint Variations. So, an inverse variation are when two variables show an inverse variation. Basically, what this entails is the fact that you have a constant of variation, and I think the book probably uses the letter A as the constant of variation. I will probably use a K. So an inverse variation, you have an X times a Y equals K. You could also think of it as Y equals K over X. So basically, if you were ever to be checking on whether an inverse variation was an inverse variation, you would do X times Y, and no matter what those two numbers were, you should end up with K. Constant of variation, A or K, however you want to look at it, your K value is the product of the X and the Y together. It's K, of course, cannot equal 0. That causes big problems. And your equation for these, your final answer would always have Y equals K over your X. So you'd always have an X in the denominator. Joint variation. A joint variation are when you have the product of, it's a direct variation. So way back in a previous chapter, we talked about direct variations looked like this, Kx. With a direct variation, it's the product of two or more quantities. So what that basically happens, it's a direct variation like this, but now you add some more quantities, like a z value. So now y equals kxz rather than y equals kx. So for joint variation, if you were looking for k, it would be equal to y over xz instead of just y over x. So an inverse variation. Two variables, x and y, show an inverse variation if they are related as follows. Basically, you take the constant of variation a, you divide by x. The constant a is the constant of variation, and y is said to vary inversely with x. Basically, again, please, whenever you see inverse variation, you should think y equals a over x, or you could think that a, the constant of variation, is the product of your x and y values. All right, let's tell whether these are direct variations or inverse variations or neither. So taking a look at this, let's solve for y for this equation. We do that by multiplying each side by 9, and you end up with an equation that is y equals 9x. All right, going back over here to even the vocabulary portion, you'll see direct variations, they actually were a number times a variable. The variable is in the numerator. So for this, the variable is in the numerator, so you would say that this is a direct variation. Look at this. This looks exactly like this right here. A constant is equal to x times y. So if I rewrote this, this would be y equals 3 over x, and this for sure is an inverse relation, or an inverse, it varies inversely. Alright, so tell whether x and y show a direct variation, an inverse variation, or neither. None of the examples that we saw ever had something being added to the variable. There was never any plus or minuses. So this is neither. This right here, let's divide by x. Because once we have it y equals something, we can easily see that this is an inverse variation. The variable, there is a variable in the denominator. Here, let's multiply by 2.6 on both sides, and you get y equals 2.6x. The variable is in the numerator. So therefore, it is a direct variation. All right, so now we have to remember some of that stuff there. The variable x and y vary inversely. So we are told they vary inversely. As soon as you hear varies inversely, like I said right here, as soon as you hear inverse variation or vary inversely, you should think a constant of variation is x times y. So constant of variation is equal to x times y. So here, x is 6, x is 3. Therefore, the constant of variation is 6 times 3, or 18. Now here, they didn't look at it this way. They said, well, y is 3, this is 6. You solve 18. You still end up with 18. So that means the inverse variation, okay, so we find the constant by doing a equals x times y. But the equation should look like y equals a over x. So y equals a, 18, over x. Now, take a look at the inverse variation equation is this. What is the y value when x is negative 9? Well, x is negative 9, so plug it in. Once you plug it in, you end up simplifying that to negative 2. So I could give you anything. I could say, well, what is x when it's 14? Or, I'm sorry, if x is 14, what is y? Well, y equals 18 over x, which equals 18 over 14, which simplifies to 9/7. That is how you set this up. So try this on your own. Follow the example 2. It's a checkpoint on your note-taking guide. Go ahead and pause the video and work it out. All right, so hopefully you paused the video and you worked it out a little bit to see if you could do it. Varies inversely, so we're looking at the constant of variation is equal to x times y. It tells us that x is 5, y is 4.4, so our constant of variation is 22. So my equation, write an equation, y equals 22 over x. All right, 22 over x. If x is 8, we put that 8 in for x. 22 over 8 reduces to 11/4, and you can leave it like that. This is how you set up inverse variations. All right, guided practice 1 to 3. Let's take a look at those. You should be looking at page 552 in your book. Number 1 asks whether this is a direct variation, an inverse variation, or neither. So 3x equals y. Well, we're solving this. It looks like this, y equals 3x. You should see it's a constant time in x. X is in the numerator. This is direct. Number 2, xy equals 0.75. Well, a couple things. You can see product of two variables. If we divide it by x, and you should say that this is inverse, an inverse relation. Number 3, y equals x minus 5. And as soon as you see that minus 5, you should say, there's something wrong here. This is neither. Yep, neither. 5 and 6, you're actually coming up with the direct variation. Number 5, well, let's see here. It says they vary inversely. So we're given that x is 8. We're given for number 5 that y is negative 1. We're told that they are inverse. So the constant is x times y. Therefore, the constant is 8 times negative 1, or negative 8. Right away, you should have the equation y equals negative 8 over x. Now, the second part of this tells us that, well, what if x is equal to 2? Well, we have this equation, and it says x is 2. So y equals negative 8 over 2. Gives us negative 4. So that's number 5. Number 6, I'd like you to try on your own. Number 6, x is 1/2, y is 12. Pause the video, work out the solution. If you've worked out the solution for number 6, you should see that y equals 6 over x is the equation. And then when you put 2 in there, you see that y equals 3. So those should be your answers for checkpoint number 6. All right, let's take a look at this data here. Determine whether m and n show inverse variation. If they do, write a model. So inverse variations have a constant of variation where their products are equivalent. I think we've been using x times y equals the constant, but here m times n. So what you're going to do is you're going to check, does 5 times 45 and 10 times 22.5 and 15 times 15 and 20 times 11, do all of these equal the same number? If they do, then it does inverse is an inverse variation. So pause the video, use your calculator or by hand, multiply all of those out. Now, if you did this, you should see that 5 times 45, all of them add up to 225. So that tells us that A is 225. If you're writing the equation, y equals 225 over x is your equation. That's part 1. Part 2 says let m equal 45. All right, well, this is where it's going to be a little bit tricky. You got to make sure that you know which one is which here. All right, this m represents our x's, so it's x right here. This would actually be n equals 225 over m. And when you plug 45 in there, you end up having it be 5. All right, do the same for this as a checkpoint. Multiply them together. When you multiply them all together, each one multiplied should become 36. So you now, not only do you know it's a inverse variation, you know that A is 36. And your equation should only take a few seconds more. All right, joint variation. A variation occurs when a quantity varies directly with the product of two or more other quantities. The equation below is A is a non-zero constant. Z equals A x y. So Z varies jointly with x and y. Now you're going to be given basically three total variables, but you follow this equation. The constant equals Z over xy. So let's take a look at this example. Z, 84, or negative 84. X, negative 4. Y is 3. The constant is equal to Z over xy. So negative 84 over negative 4 times 3. So the constant of variation, A, should be 7. Now our equation can be rewritten as Z equals 7 xy. So the first part is always finding the constant. The second part is writing the equation. Now it says find Z when x is 5 and y is 2. It gives us this, we have the equation, just plug in those points. 7 times x times y equals 70. This is a joint variation equation. All right, guided practice 9 to 12. All right, so those next guided practices are on page 554. Number 9 tells us x is 1, y is 2, z is 7. So it tells us the variables vary jointly. Use the given values to write an equation relating them together. So let's find the constant of variation is z over xy. That means it's 7 over 1 times 2, which is 7 halves. So once you do this part of the work, the equation should be a piece of cake. Z equals 7 halves xy. That's part 1. Part 2, they tell us that x is equal to negative 2, y is equal to 5, and you're supposed to find z. So z is 7 halves times 5 times 2, and your final answer should be, times negative 2. Final answer should be negative 35. All right. I think you can probably take on 10 and 11 on your own, even 12. I'll tell you that the answer for number 10, I would pause the video at this point if you want to actually know what you're doing. So the equation for number 10 is z equals negative 2xy. And then the answer should come up with 20. Number 11 looks like z equals negative 3 halves xy. And your answer would be 15. So I think you got that down. All right, comparing the different types of variations. So writing the equation given this information. M varies jointly with N, P, and Q. So M varies jointly. That means M equals a constant of variation times the product of all the extra variables. So remember, this A is the constant of variation, NPQ. B, R varies inversely with S. Inversely means it's the fraction, so A over S. X varies inversely with the cube of y. So again, it's a inversely a over the cube of y. So y cubed. All right, the next one here, number D, it says they varies jointly with x and y and inversely with m. So now you have to combine the two of them. It's jointly with x and y. So jointly means they're being multiplied, and inversely means it's m is in the denominator. So you still have a, but it's jointly with x and y, so it's axy, and then inversely with m. So whatever is inversely is in the denominator, whatever is jointly or directly goes in the numerator. The last one here, t varies directly with u and inversely with w. So again, directly is in the numerator, inversely is in the denominator. So the constant of variation is always in the numerator. So directly with u and inversely with w. So if we take a look at checkpoint, it says that the variable z varies jointly with x and y. So we have jointly, that means a equals the, I'm sorry, it means that the whatever the z is, z varies jointly, that means everything's in the numerator, with x and y. So z is negative 44, a we don't know, x is 4, y is negative 1. So that means when we work this out, a is equal to 11. So my equation is z equals 11xy. The next part says that here is find z when x is 6 and y is 3. So we use our equation and we plug it in there. And 198. Write an equation that varies jointly with y and z, and inversely with the square of t. So remember, jointly and directly are in the numerator. Inversely is in the denominator. So we have that x varies jointly with y and z, and inversely, so denominator, with the square of t. The square of t. This is your equation. Whatever is inversely is in the denominator. Whatever jointly is in the numerator. All right, that's pretty much it. Take a look at your practice problems. I would look over a few of them before you come to class. So then we'll work on these problems throughout the course of the class period. Good luck.